Hi guys, let's look at the next exercise. But before we start the next exercise, let's quickly revise the trigonometrical ratios that we learned in the previous exercise. So there were 6 ratios. We are basically talking about a right angle triangle, and in this case my reference angle is A. The 6 ratios are 3 basic ratios and the reciprocal of them. So for the first one, sin A, it's equal to perpendicular upon hypotenuse, or also known as opposite upon hypotenuse, in this case BC upon AC. The reciprocal of this is cosec A, which would be the reciprocal, which is AC upon BC. Cos A is base upon hypotenuse, or also adjacent upon hypotenuse, in this case AB upon AC. The sec A is opposite, or rather reciprocal of this, which means it is AC upon AB. The next one is tan A, which is perpendicular upon base or opposite upon adjacent, in this case BC upon AB. Cot A is the reciprocal of this, which means it's equal to AB upon BC. And then the last relation that we did was tan A is equal to sin A upon cos A. So let's look at how sin A in this case is BC upon AC divided by cos A, which is AB upon AC. AC and AC gets cancelled. This is equal to BC upon AB, which is nothing but BC upon AB is nothing but tan A. So these are the 6 relations that we did, 3 basic and 3 reciprocal, and tan is equal to sin upon cos. Good. Now let's look at some questions, but before I start, let me just erase what I wrote here. Good. Let's look at the question. This is question number 1, or rather question 2 in exercise 22A. Now we need to find this if I need to find any relation for y. Similarly, I need to find this length so that I know total of BD. So in right triangle ABC, using Pythagoras theorem, what I get is AC square is equal to 8 square plus 6 square. This is 64 plus 36, which is 100, which means AC is equal to 10. So this is 10. Now let's look at the big triangle. In triangle ABD, using Pythagoras theorem, I get 17 square is equal to 8 square plus BD square. 17 square is 289, minus 64 would be equal to BD square, which means BD is equal to 289 minus 64, that's 225, the square root of which is 15. So this total length here is 15. Done. So let's look at what we need to calculate. So number 5, this is sin x, which is for this big triangle, it will be equal to perpendicular, which is AB upon hypotenuse AD, which means 8 upon 17. So that's the first part of our question. Next part is cos y. So we are looking at the small triangle here. Cos y would be equal to base, in this case BC upon hypotenuse, which is AC, which is 6 upon 10, which is 3 upon 5. Done. So first part done, second part done. Third part says tan x sin y cos y. Okay, so 3 times tan x. Tan x would be perpendicular upon base, so AB upon BD, minus 2 into sin y. Sin y would be perpendicular, which means AB upon hypotenuse, which is AC, and plus 4 cos y. Cos y we just calculated, it is 3 upon 5. Cos y we have calculated. So let's substitute values and see what we get. So point number 8, 3 times AB is 8 upon BD is 15, minus 2 times AB, which is 8 upon AC, which is 10, plus 12 upon 5. So this is 2, 1, 2, 5. This is 3, 1, 3, 5. So this is 8 by 5 minus 8 by 5 plus 12 by 5. This and this gets cancelled, which means this is equal to 12 by 5, which is 2 by 5. We don't write your answers in improper fraction, we convert this into mixed fraction. Good. Let's look at the next question. The next question that we are doing is question number 3. Question number 3 says, in the diagram given below, triangle ABC is right angled at B and BD is perpendicular to AC. Okay, so we have two right triangles. We need to find cos angle DBC, which means I need to look at this angle, and cot angle DBA, which means I need to find for this angle. Now I have the option of using Pythagoras theorem. So this is 5, this is 12, which means this will be 13 because this is the Pythagorean triplet. Now I can find this value separately, and this separately using Pythagoras theorem in these two triangles, or I can use a second method. So let's look at the next method. So let's this angle be X. So I'm looking at the big triangle ABC. If this is X and this is 90, which means this angle is 90 minus X, because the sum of three angles will be 180 degree. Good. Now let's look at this small triangle BDA. Now in this BDA, this angle is 90, this angle is X, which means this angle here is 90 minus X. Okay. Let's look at this small triangle BCD. This angle is 90, this angle is 90 minus X, which means this angle is X. Let's see how does this help me. Let's just write this down. Number 1, in triangle ABC using Pythagoras theorem, what I get is AC square is equal to 5 square plus 12 square, which is 25 plus 144, which is equal to 169, which means AC is equal to 13 centimeter. So AC is 13 centimeter. Next, let angle BAC is equal to X. That's the first thing that we've done. So in triangle ABC, what we have is angle X plus 90 degree plus angle BCA is equal to 180 degree. So this is angle sum property, which means angle BCA would be equal to 180 degree minus 90 degree minus X, which means angle BCA is equal to 90 degree minus X. So we've got this angle as 90 degree minus X. Now in triangle ABD, I have X plus 90 degree plus angle ABD is equal to 180 degree. So similarly, angle ABD is equal to 90 degree minus X. Next, so we've got this as 90 minus X, we've got this as 90 minus X. Now let's look at triangle BCD. In triangle BCD, I have 90 minus X as one angle, I have 90 as one angle, and the remaining angle is angle DBC. All this is equal to 180 degree, which means angle DBC would be equal to X. 90 plus 90, 180 gets cancelled. So I have got this as X. Now let's find out what we need to calculate. So cos angle DBC is equal to cos angle DBC is equal to cos X. So in triangle ABC, cos X would be equal to base, which is AB, upon hypotenuse, which is AC, which is 12 upon 13. Done. So that's the first part of our answer. Cos X would be equal to 12 upon 13. Next we need to find this cot angle DBA, and cot angle DBA, which is this angle, is 90 degree minus X. So this is cot 90 minus X. Now in triangle ABC, cot of 90 minus X, which means my reference angle here is C, it would be equal to base, which is BC, upon perpendicular, which is AB. So this would be equal to 5 upon 12. So cot angle DBA would be equal to 5 upon 12. Good, very interesting question. Let's look at the next one. The next one that we do is question number 4. Again a similar question, but let's still go ahead and solve it. Again we use the similar technique and the similar logic. So if this is 3, this is 4, then AC is equal to 5 using Pythagoras theorem. Let's take this angle as x. So in the big triangle, this angle is 90 minus x, this angle is 90 minus x, and this angle is x. Let's write that down. Number 1, in triangle ABC using Pythagoras theorem, I get AC square is equal to 3 square plus 4 square. Therefore, AC is equal to 5 centimeter. Next, we have assumed that one angle is x. So let angle ACB is equal to x. Therefore, angle CBD is equal to 90 degree minus x. Angle DBA is equal to x, and angle CAB is equal to 90 degree minus x. Let's see what we need to calculate. Tan angle DBC, which is equal to tan DBC, which means tan of 90 degree minus x. So in triangle ABC, tan 90 degree minus x would be equal to, so this is the base, so perpendicular upon base, in this case CD upon BD, which is equal to, oh my mistake, we're looking at the reference angle 90 minus x in the big triangle. Sorry, I was looking at the small triangle. We don't know the values, so that's why we've done all this calculation. So tan 90 minus x, which is this angle here, would be equal to perpendicular, which is BC, upon base, which is AB, which is 3 upon 4. So that's the first part of the question. Next one is sine of angle DBA, which is equal to sine of angle DBA is sine x, which means in triangle ABC, sine x would be equal to, so this is the reference angle C, would be equal to perpendicular, which is AB, upon hypotenuse, which is AC, which means 4 upon 5. Done. Let's look at the next question. The next question that we do is question number 5. Very interesting question. Let's look at this. In triangle ABC, AB is equal to AC is equal to 15 centimeter, which means this is a isosceles triangle. Is it right angle as well? No, because Pythagorean triplet is, this is not a Pythagorean triplet, which means this is not a right angle triangle. Good, let's just draw this rough diagram for us to understand it clearly. So this is triangle ABC. AB and AC are equal to 15 centimeter. The diagram is not given. I am making it for my understanding. Right? I always recommend and suggest draw a rough diagram. Okay. And BC is equal to 18 centimeter. Now, since we need to figure out a right angle triangle, let me drop a perpendicular from A onto BC, right? And let this be AD. So point 1, draw AD perpendicular to BC. Now, since this is an isosceles triangle, in this case, the altitude is equal to the median, which means AD divides BC into 2 equal parts. Let's just write that down. Since triangle ABC is isosceles, therefore AD bisects BC, which means BD is equal to CD is equal to BC upon 2 is equal to 9 centimeter. So this is 9, this is 9. We need to find cos angle ABC. So this is my reference angle. Cos would be base upon hypotenuse, which means 9 upon 15. So that should give me my answer. Good. So cos angle ABC. So we are looking at in a right triangle ABD. So this is the reference triangle, which would mean it is equal to base, in this case BD, upon hypotenuse, which is AB, which is 9 upon 15, which is equal to 3 upon 5, which means cos angle ABC is equal to 3 upon 5. Perfect. That brings me to an end of this video. Before I leave, let me mark some homework question for you. Question number 1 and question number 6. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye-bye.